we're given some information about some donuts. Okay, Homer's purchased a dozen, so there's 12 out there somewhere. 3 of them are round with sprinkles. 2 of them are bars with sprinkles. But then you've got the glazed section. So 2 of them are round glazed, and then the rest are bar glazed. So the rest usually means I'm going to ask about that. So so far you've got 3, 2, and 2. That accounts for 7 of them, right? So the rest means 5. Okay? So we've got the 5, we've got the 2, the 3, and the 2. That should give you the dozen that we're told exist at the beginning. Okay? So if Homer wants to select a bar donut, how many possible donuts can he choose from? Well, you've got the 5 glazed bars, and you've got the 2 that are also bars here. So 2 bars and 5 bars give you a total of 7 bars. Okay? So how many can he choose from? There's 7. Now, given that Homer selects a bar donut, okay, let me ask a different question. What's the probability that he chooses sprinkles? Just generally speaking, what's the probability that he chooses sprinkles? There's 5 out. There's 3 and there's 2, so there's 5 out of 12 in terms of the sprinkles, right? But when we talk about knowing something about it, this is conditional probability. Given that, anytime it's a given that, you got to think about the fact that your denominator here, you've got a probability of something out of something else. The denominator is not the 12 donuts that we're looking at. If it says given that he selected a donut, then yeah, this would be 12. But here it says given that he selects a bar donut. We need to find out how many bar donuts there are. So that means if we know it's a bar donut, our denominator then needs to be what?
7.
It needs to be 7. Okay? Because that's why this question was asked over here. Whoops. So, given that it was a bar donut, what are the chances that the one he chooses has sprinkles on it? Well, how many of those 7 actually have sprinkles?
2.
And there's 2. Now, I put it out here off to the side because it's good to usually jot something down like that, because every once in a while it's going to be able to be reduced. And to be honest, I should have probably put it here, and if it reduces, I'll just put equals whatever. But that's it, essentially. Now, we look at the next problem here. It says a box contains 7 large red marbles, 5 large yellow marbles, 3 small red marbles, and 5 small yellow marbles. So marbles are broken up into large and small, yellow and red. Okay? And we're given this. If a marble is drawn at random, what's the probability that it is yellow given that? Given that means they are saying there is a denominator here that is going to be different from the overall thing. If you look at 7, 5, 3, and 5, that's a total of 20 marbles. The denominator shouldn't be 20. It should be 12. It should be 12 because we're talking just large marbles here. So there's 7 large and 5 large. But the question is, what's the probability that it's yellow? Now, be careful, because if you're just looking at yellow, there's 5 yellow marbles here and there's 5 yellow marbles here. We're not talking about all 10 of those. Just the 5. It's the 5 ones. See, and this is how you'll want to kind of look at that. These 5 refer to the ones that are both large and yellow. Okay? So when we're talking about the probability of the intersection of A and B, this is technical jargon that you may or may not be even care about, divided by the probability of B. Now this is saying that if we understand that the probability of A knowing B, this is terminology that I kind of use in my AP Stats class. This is what the question's saying. Probability of A knowing B, where this vertical line here means if I know something about it, and if I know B is true, then I just simply want to say that my denominator is going to be all of the B. Okay? And if I'm saying what's the probability of A if I know B is true, then we're looking for the intersection of those two things, and that goes in the numerator. So we're talking about yellow ones that are also large. There are 5 of those. That's how we got this number on top. But it says given that it was large, I want to count up all the large marbles, and that's why the 7 and the 5 go to the bottom. It's not, I mean, it's adding stuff that you can usually use digits on your hands. That's the math involved. But it really does, it is something you've got to kind of dig into the problem, look and see what you've got. So the final answer is 5 out of 12 after you do all that hoopla.